Ah, yes! Winner! Alright guys, today we're back in my house. We're gonna swap out this electrical panel. It's got a whole bunch of code violations going on. I'm gonna take you all the way through it and we're gonna have fun. A couple things before getting started. I'm excited. I got a new pair of pliers. These are 1000 volt rated, good for solar energy work, and my friend blew out my old pairs. So check those aside. I'm ready to rock. Here's the deal, step by step. First thing I'm gonna do is I'm actually gonna document exactly what I've got here. I've got some pencil markings and labelings on the inside cover, and I just want to take a picture of everything that's happening. If I'm in a customer's home and I'm doing this work, I'm actually taking a picture of the floor, the tile, the wall, so that I've got proof of what was there before I started and I don't get blamed for someone else's problems. But in this case, I've got a drop cloth down, I'm protecting my environment, and I've got a picture of what is. We're going to take the panel cover off, and we're going to walk you all the way through this. Let's rock. Maybe sometime you and I will do a time trial. We'll see who's faster. But guys, we're going to drop all the materials and the materials list into the comments below. We're going to drop the code references for what we're talking about. We're going to talk about the silent killers and the number 3 cause of fire, and trying to keep everybody safe. There it is. All right, easy taking the panel cover off. Don't rip the heck out of the paint. A lot of times these things are painted on. You can see right down that edge. Ah, it's just like what the shark said after he ate the clownfish. That's funny. We've got code violations going on here. There's no connector on the incoming conduit with the feeds. There is no bushing on this wire entry. We've got double tapped connections at the top of the panel. All right, so what I'm going to do is I'm going to finish documenting what's happening here with pictures. I'm going to test the current situation so that if there is something funny that's existing, I'm fully aware of that and I'm combating the issue as we go. I don't want to be surprised at the end of the project. And I'm doing this all with the power on right now because I want to extend my battery life for my lights, my power tools, and I want the house to have power as long as possible. We're reading 250 volts on the incoming feeds, which is good. We're always going to test hot to hot, hot to neutral, hot to ground. Get a good picture of everything that's taking place. I do see this is a sub panel. That means that the main panel is elsewhere and is feeding into this panel. At this point, grounds and neutrals have to be separated, and I'm going to tell you why. But they're not. See here, ground, neutral on the same terminal bar. Let's see if the housing is grounded. And the answer is yes. The cabinet, the metal cabinet and enclosure itself is grounded, but I don't see anywhere where it's well grounded. We've got more double tapping going on here. Plenty of issues to correct, plenty. So right now all my circuits are looking good. And for reference, double tapping is what's going on right here. It's where there are 2 wires under one terminal, and just gauging by these terminals and their physical shape, these terminals are not rated for more than one conductor. So you create an unsafe condition where the conductors are not properly seated and there's risk that one of them is going to come loose, or that the terminals will be overstuffed. It changes the torque specifications, like it just throws everything off. It's not according to the design. Right now we look pretty good. I'm going to label all of the hot conductors that are landed on the breakers with the labels that have been provided. They may not be accurate, they may not be thorough, but at least I'll have all the information transferred to the new setup and then I will go through and I will thoroughly label all the breakers. Quick tip about labeling breakers. Labels may not be occupancy specific. Can't say Timmy's room. You've got to say northwest bedroom. So you can't have labels that say lights, 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 plugs, plugs, plugs. Every label needs to be unique and distinct from every other label. But I'll at least capture what we've got. I'll transfer it to the wiring. And then in this case, I don't have any white wires that are being used as hot conductors. All of these are black, and all of my whites are landed on the neutral bars down here, and so I don't have any risk of confusion. But sometimes on a 2-pole breaker, that second wire is white, and in that condition it's real important to label that so you don't actually send the wrong voltage to an expensive appliance. Alright, so we've identified all of the circuits that have any kind of labeling connected to them. We've taken our measurements, we've evaluated what is, we've captured the information through photos, and now we're ready to turn off the power. Shut it off, Titus! Alright, so I'm going to actually not use my non-contact voltage detector. I'm going to use my digital multimeter. I'm going to use I'm dealing with a lot of power here. I'm going to use my most reliable tester to verify that everything has been shut off and we're looking good. Again, measuring hot to hot, hot to neutral and ground. But I'm going to do one more thing. This is the first of the silent killers. This house was built in 1938, and there's a really good chance that at some point in some remodel, somebody has accidentally backfed a circuit such that these wires should be fed from these breakers. And they are, but there's a chance that there's backfed current that's coming from some downstream connection back across the wire to the breaker itself. So I'm going to turn on my non-contact voltage detector, and I'm just going to check everything real quick. Even though the main feeds are off, there's backfed potential, and in this case there's not. So we're in the clear, and I'm going to start taking things apart. Backfeeding could come from anything that was connected. Like, let's say there are 2 receptacle circuits and somebody just bridged and accidentally connected 2 circuits way downstream, and such that they're both feeding the same set of wiring, even though there should be a separation between the circuits. And so now you've put 2 breakers in parallel with each other, such that you have to turn off both breakers to isolate that wiring and that power. At this point, I know what every conductor in this box does, and I'm comfortable just kind of taking mental notes. That one was tough. Taking mental notes along the way for anything that I need to know to put this back together properly. So one thing that's happening here, and the reason that these mains on the top are double tapped, is that there's a 60 amp feed into this box, and then there's a full pass-through out of this box, and I'm assuming at this point that goes to another sub panel upstairs. So I've got a correction for that. Look at that, that's been jumpered. Now here's an age-old question right here. Is that legal? Connections in the main electrical panel. You guys are going to fight about this all day long, but this is what the code says. The code says that connections inside electrical equipment are permitted if there is sufficient space, which in this case I'd say there is, nothing was harmed by the presence of the connection, and if the equipment is rated for the purpose. Now that's the question. Most manufacturers don't say, yeah, go ahead and make auxiliary connections inside the main panel, and some inspectors will not allow it. In our jurisdiction, this will pass, but not in all jurisdictions. So there's a lot of room in the code for interpretation on that point. All right, so I've identified 2 things I didn't notice immediately, and one is the main neutral feed coming in is really not clearly marked. I can't see any distinguishing coloration on it, so I'm going to go ahead and mark it with 3 wraps of white electrical tape, which is a code-compliant manner for marking a neutral. And I'm going to just make sure that that does not get mixed up. The consequences of mixing up a neutral and a hot conductor could be devastating across the house. Explosion, like immediate, just fry, cook, boil. And then I've got this conductor that's not being utilized, my only red conductor. In order to get it pulled out and back in, I've got to take the wire nut off here. But I'm making a firm mental note. Do not terminate the red conductor. I'm going to start pulling apart all the connections here. And I'm hoping I've got all the right parts and there are no snafus, and I'll be able to put it all back together too today. I know my wife would love to have power turned back on. All right, I've got this little wrench. This guy is real handy dandy. Loosen, tighten for 1/2 inch lock nuts. And what he's going to do for me, he's going to get me into tight spaces to be able to twist off. Whoops. Lefty loosey, Joel. Be able to twist off all these lock nuts. And as soon as they're loose, I spin them off by hand. But if you don't have a little wrench like this, I'll show you what the alternative is. A little lock nut wrench will be in the description. Take a flathead screwdriver, find the shoulder of the lock nut. I'm using, and just get them all started, just like that. There it is. Well, this old cloth covered wire is fairly susceptible, so it looks like I'm being rough on it, but I am actually trying to prevent it from abrasion. Take a look at this one right here. Look at that. 1, 2, 3 places where it's split open. This house is due for a whole house rewire. And in fact, that's exactly what I'm going to do. I'm going to bring you into it in a later video. Now I'm ready to lay out the new electrical panel. Here it is. A couple things important to note here. One, you're going to notice that this breaker is in side-to-side motion. This would be a code violation to quote-unquote turn it upside down if the breaker was oriented in such a way that down was on and up was off. That'd be a violation number 1. None of these breakers can be oriented in the vertical position because half of them will be wrong if the panel was to be turned on its side. And because our main feeds are coming in the bottom, we're going to orient the main feeder breaker here at the bottom as well. In this case, neutrals and grounds are separate. Here's the second silent killer, besides backfed currents, is a failure to separate neutrals and grounds. See, in this case, we're after the first means of disconnect, which is outside on the carriage house. So we have to separate neutrals and grounds, because if we don't, then the neutral current will actually energize grounding components. So you'll have components that are meant for safety and grounding for both personnel and property, and they'll become energized with neutral current and actually turn them into a hazardous condition. This conduit right here is the best example of that. There's a metallic conduit bringing these service conductors in, and right now, that metallic conduit in the original installation, that was energized with neutral current all the way back to the main distribution. So if there is a poor connection on that grounding path, let's say lock nuts and fittings that weren't snugged down, those could start to arc and spark with neutral current. If a personnel came in contact with that metallic conduit and they became the pathway of electricity, it could be a deadly shock. Here's one thing that we all learned in school, even in physics class, that's wrong. And that is that electricity takes the path of least resistance. That's flat out wrong. Electricity takes all paths, and primarily the path of least resistance. So all of this These conduits, these fittings, were energized in the current installation by neutral current because neutrals and grounds were not properly separated out. So in the new panel, we have a separate grounding bar that's come like this from the manufacturer, and all of our grounds will be terminated here. If we've got some that are too short, we could add another auxiliary grounding bar, and that's what these holes are for. They can be drilled and or tapped to the cabinet. So the cabinet will be grounded, the ground bar will be grounded, the incoming conduits will be grounded, and everything's going to be safe. So at this point, I've got to lay out the new panel. I've got a rigid steel conduit coming in the bottom. What I'd like to do is start my new panel here and install it. I've got to be mindful that the upper limit of the top breaker is 6 foot 7 inches above the floor, so I don't want to make it too high, but as long as I'm underneath that, I'm code compliant. And I am going to probe the wall a little bit to make sure I've got a clear pathway up there. I'm just going to take a scrap of wire, a fish tape, doesn't have to be anything glamorous, to make sure I've got the space before I go cutting the wall open. So let me lightly pencil on the wall what I'm dreaming of and imagining. Ooh, and this old panel's a little bit more narrow than our new panel. Of course. Well, let's start with that. Probing beside the panel, I realized that my extra capacity is on the right side. The new panels are going to be sold at 14 3/8 inch width. That should be a nice fit inside a standard stud cavity. So I'm going to hug the right side, line up the bottom. I've got a level on the side of it here. That is about where I want to be. I know you carpenters like your carpenter's pencils, but I've got an eraser on mine. Alright, so I'm probing up inside the wall. And I want to know, before I go cutting it open, that I've got space to do that. Feels pretty good. Feels pretty good. I'm going to open another hole on this side. Yeah, I'm feeling for any kind of obstruction that's up there. It feels like the wall is free and clear. Of course, I'm fighting the wiring that's up there. I'm feeling that. I think I'm willing, at this point, to take the risk. Clear out some of the stuff I don't want to get messed. And still good?
Yeah, we're on.
So I'm taking it nice and easy here as I'm opening things up so that I don't overcommit. I'm hitting something right there. It's gonna get dicey before it's over. I don't want to plow through things that need to be given a little bit more consideration. All right, I've got a stud there. Whoo, it's gonna be dicey. Make it work. Nice and easy. All right, that's all a solid stud right there. Let's open this up. It looks kind of aggressive and abrasive, but it's actually safer for the wiring if you're kind of breaking things out of there as opposed to cutting through it and risking the wiring. So Getting some good, this is the kind of stuff viewers want, right? A little bit of mayhem. There's a little space over there too. Okay, I'm ready to exploit it. Let's see what my overall width is now that I've opened up both sides of this equation. Oh, shoot. It's only 14. Surgery. We need another 3/8 of an inch, and that's not going to come without a fight. Whew. So at this point, this stud has already been carved a little bit. We've lost probably a 1/2 inch off this side. I need another 3/8 of an inch. I'm very reluctant to pull it off this stud here, so I'm going to come over to this stud and transfer my markings over a little bit, and I'm literally going to trim this stud 3/8 of an inch all the way down. Now, if you're an engineer, an inspector, a builder, a contractor, a carpenter, let me know what you think about that, because generally speaking, I'm gonna say I'm willing, especially on a beefy corner like this, to take a 1/2 inch off one stud, but I know some of you are in freak out mode right now. Let's go. You'd be bleeding out the knuckles at this point if you're not wearing gloves. Can someone help a brother out? No wood chisel on the premises. I've got the last little bit on the back side of this 2x4 that needs to be cut out, and my panel is 4 inches deep. So this is a 3.5 inch wall plus a 1/2 inch of plaster. I need the full depth to be clear so I can fit that panel in there, and I'm already afraid it's going to be a pretty tight fit as it is. All right, so now I'm going to lay things back out in kind of a logical fashion. All right, so I'm going to strip all these back with an MC stripper or a BX cutter. This is called BX right here, and it existed from early 1900s all the way through the 1940s, I believe. It's the second generation of wiring in homes in America. The first was knob and tube. The second is BX. It does have this kind of cloth-looking outer insulation, which tends to be in better shape than knob and tube wiring does. So I'm going to remove the connectors, strip back a length of outer jacket, reseat the connector, and the reason for that is I want to make sure that everything's going to reach nicely, lay nicely inside the panel. So it is a relatively time-consuming extra step. It will take me another 20 minutes to strip this back, but it's going to ensure that I've got enough wire length to do exactly what I want to do. In this case, if I were to just bring it up and land the connector in the top of the panel, that's getting pretty short right there. The other thing is these are 1/2 inch connectors. This one's a 3/4 connector. But what you'll recognize in the top of the electrical panel, the 1/2 inch connectors are actually measure 7/8. The reason for that is because the internal trade size nominal diameter of things like electrical metallic tubing conduit, that's actually a nominal 5/8, 1/2 inch. And so by the time you get the outer diameter of the fitting itself, you're up to about 7/8. So this is a 1 1/8 for the 3/4. That's a 7/8. I'm going to punch them all out in the top of the panel, one per, no extras. I want all the holes to be closed and sealed when I'm done so that if there's a heat incident situation, that's contained in the panel as well as possible. And let's go. Check this little guy out right here. See if oh, there he is. Anti-short bushing. I'm going to hang on to every one of those because I'm going to slip it back in. Because what it does is it protects the wire from those sharp metal edges. Those things have all kinds of funny names. Pilgrim hats, red toppers. I don't even know. You comment below. There's probably a half dozen other names for those too. All right, I'm doing this once just for you guys. In case you don't have an MC cutter, you don't want to spend the money. What I did was I bent it pretty hard and I broke it. See, I broke the jacket. Now you don't want to do that unless you're fixing to cut it. So I've got my tin snips. I'm going to slice right across that line. I might need to work it open a little bit. There it is. Get a little bit more purchase in there. Come on. It is steel, so it's a pretty heavy jacket, and this has got a pretty small mouth on it. Come on. Come on. I'm getting through it, but I'm kind of gnawing my way, man. This is tedious. This is just for you guys. Oh, it's terrible. Ah, there it is. Okay, if I had a larger mouth on that, it wouldn't have been so bad, but these things they're kind of tiny. So I made it. I'm going to ease it off. I don't want to strip the insulation off my wire. I'm holding the wire straight on this end. Ah, there it goes. I'm going to preserve my red label here that I made, my circuit identifier at the start of this project. Easy, easy. There it is. Come on, let's go. Whew. Got it. One down. 2, 3, 4. Another one. 2. So at this point, I'm going to measure the center of the conduit here, and I'm going to transfer the mark to the bottom of my electrical panel so I can drill out for this 1¼ conduit. So I'm at 2½ inches off the wall, 4 inches off the side, and I need to make sure that I'm marking in the right location because it's easy to invert those measurements. So start with the panel in its proper orientation. I'm going to be in this bottom right corner. I'm going to flip it over, being extra careful. Measure twice, cut once. 4 inches off the side. It's going to be here. I'm 2½ off the back. Nothing's been easy so far. Nothing's been easy, but we're overcoming all of it. Always drilling out the hole, trying to stay on the shoulder between the knockouts, and it blew out. At this point, my bit's just gonna bounce around in there and it's not gonna stay in one place. So I've got a couple clamps here, a block of wood. I'm gonna show you how to overcome yet again. So I'm gonna clamp this wood on here. I'm already through the metal. If I wasn't, I'd wanna take the hole saw off, but I've already got my pilot hole. Come on. And now I'm gonna hold the panel with my knees. I like the fact that the wood is there, so I'm not putting a bunch of metal shavings into my electrical panel and parts. It's gonna work, guys. It's gonna work. I'm actually gonna reduce the speed for metal cutting. It feels good to go fast, but it's better on the cut to go slow. I was trying to go so easy. I popped those knockouts out. Look at that. It's just a mess around here. It's a mess around here. I've got another trick for that, guys. As I stated earlier, you don't want to have open knockouts. And what I'm going to have here is partially open knockouts, but it ain't over till it's over. It ain't over till it's over. Look at that, get all those metal shavings out of there. All right, let's land this thing. Hopefully it fits. No guarantees. Absolutely no guarantees. Start lacing these in here one at a time, as gently and easily as I can. Slow is smooth, and smooth is fast, y'all. This one should also be a 4-conductor cable. It's not. I've got things to fix. It's not over, and it won't be over today. Easy. This is the hardest part right here. Oh, I've got one connector short. Look at that. Ah, yes! Winner! Uh-oh, look at that. See, we want the panel to be flush with the wall, so we are going to drive it as such. All right, now we get to land all of the connectors, bit by bit, into the electrical panel here. And slide in the lock nuts. Look at those old-timey lock nuts. Look like a TIE fighter or something. Slide those lock nuts up one at a time, keeping tension on the wire to hold it into place. And it's just a tedious task. I'm going to hand tighten everything in, and then I'm going to come back and snug it, because with the BX, that metal-clad jacket we've been working with and fighting the whole time, that is the ground path. You'll notice there's a hot, a neutral, no ground conductor. the jacket itself is the ground, so it's got to be firmly connected, tightly connected to the electrical panel in order to continue the ground path. Now, some of y'all are going to ask, isn't this panel enameled? Are we actually going to have a good ground path? And should we put a 1/2-inch bond bushing on every one of these? My answer to you is, that's not a bad idea. All right, this is actually a really important little component called a bonding bushing. And what I'm going to do to spin it on there is I'm going to remove the lug. Oh! Okay, I thought I lost a part. I didn't. I'm going to slide it on there. And one thing that I was mindful of when I was lining up my hole to drill for this is I wanted it far enough back from the lip of the panel that I could spin both a lock nut and a bond bushing, which I almost forgot my lock nut, onto this. Lock nut is going to be for mechanical securement. Look at that, right on there. And I'm going to snug that down as good as I can, and hopefully those threads aren't all messed up. Sometimes that's why they don't use lock nuts, right? Because the threads get rusted, deformed. Oh, it's going on. That's beautiful. I'm going to have to fight it the whole way, though. But I'm going to fight. And now our bond bushing. And because this is a metallic conduit coming in the bottom, the bond bushing is real important, and it's going to fight me too. It's real important to get on there because I've got number 4 conductors or larger, because I want to secure the grounding connection of the panel to the conduit itself. That's where this bonding bushing comes in. And there's a terminal, mechanical terminal, that is added to the bond bushing to then secure the electrical connection to the conduit. Ooh. My mechanical terminal. Oh, yeah.
Sorry, the active process of securing.
Oh, my mechanical terminal is in place. I've snugged it down, and I'm going to remove the outer jacket of this wire, which is pretty heavy and kind of tedious. But the reason for that is it's not green. And grounding and bonding conductors are required to be either green or bare, so I'm going to make it bare. I could use green tape and label it at each end or along its entire length, but I'm just going to strip it back. So at this point, I am connecting my bonding jumper from the terminal on the ground bar to my bonding bushing. Oh, come on. Come on. No, there it is. Oh, it's tedious. Oh, that's tedious. There it is. I'm going to do the wiggle and seat method, where I'm going to take that stranded conductor. I'm going to wiggle and seat, and I've got very little working room, so I'm going back and forth. Come on, come on. You can do it. All right, that's good. Got quite a bit of leverage on that. I'm going to bring it in here, do my bonding bushing, cut off the extra, secure it down. Do the same thing on this end, wiggle and seat, wiggle and seat. All right, snug this up because there's a little movement in there. There it is. And I always leave a little extra whenever I can. That's just for serviceability. Make it easy on the next guy. Next guy might be you. All right, now it's time to secure a panel in place and terminate all of our wires. My lovely number 2 square drive drywall screws. I'm going to pull the panel to flush. And one thing you want to be mindful of, if your opening is a little bit large, meaning that gap on the side is too big, what you'll do with the screws, you'll actually pull the panel out and you'll misalign your panel cover screws. So you might need to slip a shim in there to keep the shape and the integrity of the panel cabinet itself so that the cover just slips on with ease. Ooh. I have to be mindful of that on this side. There it is. All right, at this point, watch your eyes around all these flying wires. Man, I've had some of these things pop up and nail me just above or below the eye. It's kind of scary. But my sequence of operations is to land my neutral conductors first. Now, take a look at this right here. That's pretty frayed. I'm not all the way through to bare conductor there yet, but like I said, my next step with these wires is a whole house rewire to get rid of this stuff. The fact that it's deteriorated but contained in the main electrical panel, and it's not actually, I'm feeling the copper, I'm feeling the bend. There's not a weak spot right there. If the copper was compromised because it had been bent and over manipulated, I would be concerned about that. But I've got the full integrity of the wire and I still have some insulation, and it's contained within the panel that has bare and exposed connections anyways. So I'm okay with that for knowing it's not going to be forever. I'm going to get to it, I'm going to replace it. I'm going to take my neutrals, I'm going to take them one at a time, kind of tuck them to the back, wrap them through. I'm going to leave a couple terminals on the bottom side open in case I take circuits out of the bottom in the future. I don't want to have them crisscrossing. So I'm going to bring it down to about the 4th from bottom. I'm going to mark it with my thumb, get my strippers into action, start cutting and stripping. So So see what we've got here. It looks almost like aluminum wire on the outside, but if you look at the cross section real carefully, that's actually a shiny little copper. So this is what's called tinned copper, and it's not aluminum wiring, and it is safe to terminate in the normal practice of copper wiring. It just looks different, but man, it really throws inspectors. Home inspectors will almost always call that out as aluminum wiring. The aluminum wiring in question is really a 1968, 69 to 1973 phenomenon, and there's also a cousin to that that's much less common, and that is a copper-coated aluminum. Both of those are somewhat concerning and need to be accommodated differently than what we're doing with some of this. The bending considerations on that wire, the sizing considerations on that wire, because it's a lesser conductive material, are different. They're separate. All right, without boring you to death, I want to bring your attention to a couple more things. One, AFCI protection. This is a $50 breaker as opposed to a standard non-AFCI counterpart, which is about $5. When I was at the store buying these, a lot of them were already cut open. I think someone had tested them, returned them. Boy, keep an eye out for damaged goods here. But this AFCI breaker, I'm going to demonstrate how it terminates, and I'm going to demonstrate how a standard breaker terminates. And this is going to be a 2-pole 60 that's going to extend the incoming feed on upstairs to another sub-panel that's located almost directly above us. One of the questions you might be asking right now is, didn't he just terminate a ground wire on the neutral bar? Because this is my neutral bar, exclusive to nothing but neutrals. I've removed the green bond screw, so this is a floating neutral bar. On this side, I've got a bonded ground bar. Well, to answer your question, this is actually an uncoated or unjacketed neutral. It's in this 3-wire with a 60-amp feed to upstairs. So hot, neutral, no ground. So that needs to be replaced, but that is indeed a neutral conductor. So here we go. I'm going to snap these breakers in, give you a good close-up. I'm going to leave a few free spots at the top of the panel for future circuits, a few free at the bottom. I'm going to land all my existing circuits in the center part of the panel. That's not a code, that's not There's no magic to that. I just want to bring in new circuits on the ends. So here we go. And BTW, I've already made sure that all my conductors are going to reach everywhere. Sometimes you'll have one or two short conductors and you want to place those first. So I've snapped that into the bus. I'm about to terminate it. I'm snapping in my AFCI, and it's real easy. It just seats in on the outside, rocks in the center. My panel's obviously still off. And so natural question, which I hope you're asking is, what is this auxiliary pigtail? An AFCI, arc fault circuit interrupter breaker, and a GFCI, ground fault circuit interrupter breaker, will both have this pigtail. And the pigtail is what's going to provide the pass-through of both hot and neutral through this circuit breaker, and it's going to be looking for that instantaneous arc. That is not enough to clear a standard breaker, but will cause an AFCI breaker to trip instantaneously. Here goes. Tuck that out of the way, and I'm actually going to grab my first circuit here. I'm wandering. The terminals are labeled. There's an N for neutrals. I'm going to take my hot conductor and I size it up, cut it and strip it to the terminal. I'm going to give it the tug test, and now I'm going to grab the corresponding neutral, which I've prematurely landed on the neutral bar. I'm going to bring it over to the AFCI breaker, cut it also to length. The code states that wiring for bedrooms, parlors, kitchens, dens, living rooms, and such similar living spaces shall be AFCI protected. So now if you follow with me, the neutral path coming in, it's not all terminated yet, but let's see if you can visualize this. My main neutral down here feeds my neutral bus. Through the neutral bus, the neutral transfers through the pigtail to the AFCI breaker, and then out to the loads at the other end of the circuit. So now this AFCI breaker is going to be properly protecting that circuit. All right, now I'm landing the main hot conductors. In this case, on a single phase residential service, it's interchangeable which one I land where. I'm not going to be reversing motors or anything crazy like that you'd have to be conscious of in a commercial setting. And I'm going to go with the same wiggle and seat method. My neutral on the neutral bar, hot conductor number 1, I might say phase A, wiggle and seat, wiggle and seat. Notice I left just that little extra in there. I'm going to do the same thing over here. Phase B, wiggle and seat, wiggle and seat. And I'm going to torque this all down to spec. The specs can be found on the devices themselves. For instance, this breaker, 55 inch-pounds right there. Torque for those terminals, 55 inch-pounds. The torque for this terminal is going to be found on the inside cover, and then all the other breakers are going to contain their own torque rating. These single pole breakers will be 25 inch-pounds. That's real common across the board, almost universal. And boy, I don't see it there. Pop this one back out and search for that torque rating. Oh, there it is. 45 inch-pounds. 45, 25, 55, and probably also 55. All right, I'm about to terminate all this into place. Last question I'd like to answer for you is, what do you do with a neutral conductor that's too short? Well, like we said, that's the age-old question. Can electrical connections, auxiliary electrical connections, be made in the electrical panel? All right, let me recap. As we're terminating these wires, we've got 14 gauge wire landing on 15 amp breaker, 12 gauge landing on 20, 10 on 30, 8 on 40, possibly 50 depending on your circumstances, 6 on 50 or 60, and that's probably all the sizes that you'll run into in the electrical panel. The last thing I'm going to do is answer the question about how to seal that back up. I've got this product called Duct Seal, and the Duct Seal is like a Play-Doh, but it's specific to the electrical industry, and it's for electrical wiring ducts and not actually air ducts. So it's real thick. It's oil based. It's gonna last about forever. It's real heavy duty Play-Doh. And what I'm gonna do is I can mold it and shape it to anything I want here, but I'm gonna wrap it around and I'm gonna fill that in, and I'm gonna create a real seal to close up those openings, and I'm going to prevent the infiltration of rodents. Man, how many times have I opened an electrical panel and found a rat's nest in here? I'm going to take this extra dust and blow it out of here with a shop vac or a bulb syringe. Get it out of there. I'm going to blow off a little bit of this extra dust. Finalize my terminations. Thanks for joining me. I welcome you to join us on the next video about surge protection. I've got this beautiful panel. Now, how do I protect the rest of the house? GFCI protection, AFCI protection, and surge suppression, which is required by the National Electrical Code.